Hey everyone, Lee from the 3D Modeler. Welcome back. In part 1 of our Victorian Facade series in 3ds Max, we imported our reference image and scaled it proportionally to real life size. Now, in part 2, we will finalize our scene preparation and start our modeling phase. So, without delay, let's dive in. Now we are in 3ds Max, and before starting our modeling process, we need to increase the resolution of the reference image in our viewport. Even if we are using a high resolution image, 3ds Max might display it in a lower resolution by default. As you can see, when we zoom in on this section of our high resolution reference image, the details are blurry and pixelated. And to fix this problem, we will adjust the viewport texture setting. And to do so, let's click on the plus sign at the top left corner of the viewport, then select Configure Viewport. A dialog box will appear. Go to Display Performance. Under Texture, we will increase the texture map resolution to a higher resolution. I will go with 4K resolution, which is 4096. Then click on Apply, then OK. And now, as you can see, nothing happened. And this is because we still need to save our project and reopen it for the changes to take effect. And to do so, let's go to the menu bar, click on File, and let's save our project by clicking on Save or by using the shortcut Ctrl+S. Now let's save our project. Let's open it from File, Open Recent, and let's reopen our project again. And as you can see now, our reference image is looking much sharper and clearer. And this is how you can increase the resolution of the reference image in 3ds Max viewport. Now let's delete this rectangular spline, select our reference image, press Z to zoom out. Now we are ready to begin our modeling process, and I will start by modeling the storefront facade. And to zoom in, I will use the zoom region tool, and I will enable it using the shortcut Ctrl+W, or you can click on its icon here in the navigation section at the bottom right corner of the interface. Now let's select the area of the storefront facade, and let's break it down into modeling sections. As you can see, we can divide the storefront facade into 3 main sections, which are the pilasters, the segmented arched windows, and the signage section. Today we'll start by modeling the pilaster section. As you can see, we have 2 pilasters, the left and the right. Each pilaster can be divided into the base molding, the shaft, and the capital. So let's start our modeling process by modeling the base molding. So let's zoom in on our base molding using the zoom region tool. For modeling such an element, first I will create a spline which will trace the outline of our base molding. And to do so, let's go to the Shapes tab, enable the Line tool, and let's create a rough spline which will roughly trace the outline of our model, which will then be refined to capture all the fine details of our base molding. As you can see, holding Shift while using the Line tool will ensure that your spline is perfectly constrained to the horizontal or the vertical direction. At any point, if you added a vertex by mistake like this one, you can delete it by pressing backspace. Now let's complete creating our rough spline. Let's add the last vertex, right click to exit the edit mode. Before refining our rough spline, a quick note. When working with concept designs or AI-generated outputs, some details may not be as clear or precise as real-life options. That means We'll often need to interpret or improvise to compensate the missing information, but always with an eye on preserving the overall shape of the modeling object. Now, let's refine our rough spline. And to do so, let's go to the Modify panel and let's enable the Vertex editing mode. And to enable it, I can click on the Vertex icon here in this menu or by pressing shortcut 1. Now, let's zoom in on the lower section of our spline like this. Let's enable the Move tool by pressing shortcut W. And now, let's start adjusting the position of our vertices so that they follow the silhouette of our concept design. Now, if I want to horizontally align this vertex with this vertex, I will use the Snap tool. And to enable the Snap tool, I will use the shortcut S, or I can click on its icon here in the toolbar. Now let's align this vertex with this vertex in the X axis, and let's continue adjusting the position of our vertices. Now, I want to add 2 new vertices on this segment. And a segment is any line between any 2 vertices. And to do so, I will use the Refine tool. And to enable the Refine tool, right-click and choose the Refine. Now let's add our 2 new vertices like this. Let's enable the Move tool again and let's adjust their position like this. In 3ds Max, we have 4 main vertex types. Corner, which creates sharp angles. Smooth, which generates gentle curves. Bezier, which provide Bezier handles for precise curve control. And Bezier corner, which combines sharp corners with adjustable curve handles. Now, let's apply these to our spline and complete the tracing of our concept silhouette. Now, let's select this vertex and convert it from corner to Bezier corner. And to do so, while our vertex is still selected, simply right-click. Now we can choose any type of vertex we need. Let's go with Bezier corner. As you can see, once we have converted our vertex to a Bezier corner, the Bezier handles appear. Now let's zoom in on our vertex. And as you can see in the gizmo, the movement is constrained to the XY plane. So when I select one of the Bezier handles and start moving it, it will move in the XY plane. Now if I constrain the movement to the X-axis, now the Bezier handle will only move in the X direction. And the same thing happened when constrain the movement to the Y-axis. Now let's constrain the movement to the XY plane and let's zoom out. Using the Bezier handles gives us full control over the curvature of the connected segment. So I will use it to create a smooth curve that closely follows the silhouette of our concept design, like this. Now let's select this vertex, right-click and convert to Bezier corner. Let's zoom in, enable the Move tool, and let's adjust the position of this Bezier handle until the segment curves nicely like this. Now we have this corner vertex, which maintains the overall curvature between these 2 segments. However, because it is a corner vertex, it will cause a sharp transition between the 2 segments. To create smoother and more natural flow, we need to convert it into a smooth or Bezier vertex. So, with our vertex selected, right-click and let's convert it to a smooth vertex. As you can see, now we have a smooth transition between the 2 segments, but we have no control on the shape of the curvature between them. Now let's convert it to a Bezier vertex As you can see, with the BC handles, now we have full control on the shape of the curvature between the two segments. Now let's zoom out and let's make some position tuning for some of our vertices. Now, if we have any corner like this one and we want to round it out, we will use the Fillet tool. And to enable it, scroll down in this menu and click on its icon here. Or add it as a shortcut, which I have already done since it's commonly used tool. Now let's zoom in on our corner and let's enable the Fillet tool and let's round out this corner like this. And as you can see, it is smoothly rounded using the Fillet tool. Now we have two vertices overlapping each other at this point here. And to weld them together, we will use the weld option in the menu here. So let's select both of them and let's click on the weld option. Now they are welded together into a single vertex. Now let's zoom out. Using the same modeling techniques, I will complete refining our rough spline and I'll be right back. And we are back with our refined spline. Now get ready to transform it into our base molding. To do so, I'll be using the Bevel profile modifier. The Bevel profile modifier is used to apply a custom or a predefined profile along the edges of a 2D shape, creating a 3D model with intricate detailing. It's commonly used for modeling architectural elements like moldings, trims, and frames, where refined contouring is essential. So let's create our 2D shape. From Shapes tab, enable Rectangle tool, and let's create a square spline with dimension 47 by 47. Now we want to rotate our shape 90 degrees. You can enable the Rotate tool using shortcut E or by clicking on its icon here in the toolbar. And to ensure precision, I will enable the angle snap using the shortcut A or by clicking on its icon here in the toolbar. This way we get an exact 90 degrees rotation. And finally, let's align it to the bottom of our refined spline using the snap tool. Now, from the Modify panel, let's apply a Bevel Profile modifier to our 2D object. Then, under Parameters, choose Classic, and let's pick our profile. As you can see, the outcome result doesn't match the shape of the base molding we are looking for. And this is because we still need to adjust the rotation of the profile gizmo of our Bevel modifier. And to activate the profile gizmo, with our Bevel modifier selected, press 1, or using the drop-down arrow next to it, then select Profile Gizmo. And for illustration, let's enable the wireframe mode by pressing shortcut F3 so that you can see the profile gizmo while rotating it. Now, let's enable the Rotate tool using shortcut E. And let's rotate our profile gizmo 180 degrees. While rotating, I am checking the amount of rotation in the status bar to ensure precision. Now, let's exit the wireframe mode by pressing F3. And here it is, the moment we have been waiting for. Our 3D model of the base molding is done. As you can see, we have captured all the intricate details from our concept design. Now, let's isolate our model by pressing shortcut Alt plus Q, and let's go to the perspective view by pressing shortcut P, and let's check our progress. And here it is, perfectly crafted with smooth and elegant lines. We have nailed it. Now let's add the finishing touches on our base molding. So let's select our reference image, press Alt plus Q to isolate it. As you can see, our base molding has a recessed panel molding, which needs to be modeled on the front and the right side of our base molding. So let's model it, but first let's exit the isolation mode by clicking on this icon here in the status bar. So we need to convert our base molding 3D model into an editable poly object. And to do so, we have two options. The first one is to select our 3D model, right click, choose convert to editable poly. Now we have converted our 3D model into an editable poly object. However, this method is destructive. It permanently removes access to the bevel modifier and the original 2D shape. The second, more flexible option is to use a non-destructive workflow by applying an editable poly modifier to our 3D model. So let's undo our last action by pressing Ctrl Z, and let's apply an editable poly modifier to our 3D model. This method gives all the flexibility of an editable poly model while retaining access to all previous modifier layers. Now let's model this recessed panel molding. First, select our object, Alt Q to isolate it, press P to go to the perspective view, then press F4 to enable the edged faces mode. Now let's enable the polygon editing mode by pressing shortcut 4 or by clicking on the polygon icon here in this menu. Now let's select this polygon, hold Ctrl, select this one to grab both. We want to insert these polygons by 6 centimeters, and to do so, with the polygon selected, right click and choose insert. The amount of insertion will be 6 centimeters and the type of insertion will be by polygon. Press OK. Now I want to recess these polygons, so I will extrude them inward by 2 centimeters. So with the polygon selected, right click and choose extrude. The amount of extrusion will be -2 centimeters and press OK. Now we are ready to model the panel molding. The panel molding is the decorative frame in the recessed area. To create this frame, we need to create a custom profile for it. Then use the bevel profile modifier on a 2D shape to create our decorative frame. So let's start by creating the custom profile. Now let's go to the front view by pressing shortcut F. And from the shapes tab, let's enable the rectangle tool and let's create a new rectangular spline with dimension 2 by 3. Now let's zoom in on our rectangular spline using the zoom region tool like this. And now we want to convert our rectangular spline into an editable spline. And to do so, with our rectangular spline selected, right click and convert to an editable spline. Since we have no accurate reference for the panel molding, I will design our own custom profile for it. So let's enable the segment edit mode by pressing shortcut 2 or by clicking on the segment icon here in this menu. Now I want to divide this segment into 2 equal parts, and I will do so using the divide option. And to find it, scroll down in this menu and here it is. The divide option allows us to divide any segment into equal parts depending on the number of vertices inputted in the segment box. So if I want to divide this segment into 2 equal parts, I will put 1 in the segment box and click divide. And as you can see now, our segment is divided into 2 equal parts using 1 vertex. Now let's select this segment, and I want to divide it into 3 equal parts. So I will put 2 in the segment box and click divide. And as you can see, now our segment is divided into 3 equal parts using 2 vertices. Now let's enable the vertex editing mode by pressing shortcut 1, and let's select all our vertices using Ctrl+A. As you can see, some of our vertices are Bezier corner, and I want to convert all our vertices into corner vertices. And to do so, with our vertices selected, right click and choose corner. Now we have converted all our vertices into corner vertices. Now I will select this vertex, enable the snap tool by pressing shortcut S, and now let's adjust its position like this. Now let's select this extra vertex and let's delete it by pressing delete. Now I want to round out these 2 corners, and to do so I will use the fillet tool, and to enable the fillet tool I will use my shortcut or by clicking on fillet here in this menu. Now let's round them out like this, and as you can see they are smoothly rounded using the fillet tool. But now at this point we have 3 overlapping vertices which need to be welded, so let's weld them using the weld option in this menu here. Now they are welded into a single vertex, and as you can see now we have finished creating our custom profile. Now let's create the 2D shape that will become our panel molding. So let's zoom out. Since our panel molding will be created inside the recessed area, we need our 2D shape to cover the whole border of this area. So we will create a rectangular spline, and to do so, from the create panel shapes tab, let's enable the rectangle tool. Let's also enable the snap tool by pressing shortcut S. Now let's create a rectangular spline that snaps to the corners of our recessed area. Now we have created the 2D shape for the front panel molding, and to create the 2D shape for the one at the right side, press V to choose right view to go to the right view, and let's create a rectangular spline for the one on the right side. Back to the front view by pressing shortcut F, and now we have finished creating the 2D shapes for our panel moldings. Now let's finish creating our panel molding, but first let's select our custom profile, change its color to something like bright yellow, and let's adjust its position like this. Let's zoom in, then let's select our 2D shape. From the modify panel, let's apply a new bevel profile modifier to it. Under parameters, choose classic, and let's pick our custom profile. Now let's switch to the perspective view to see our progress. As you can see, our panel molding is still not aligned correctly. So first, let's adjust the rotation of the profile gizmo. With our bevel profile selected, press 1 to activate our profile gizmo, and let's rotate it 180 degrees around the y-axis. But as you can see, even after adjusting the rotation of the profile gizmo, our panel molding is still not aligned correctly. This misalignment is due to an issue with the first vertex in our custom profile. The bevel modifier uses this first vertex as the starting point to define the path for shaping the panel. Let's switch to the front view by pressing shortcut F. Let's select our custom profile, press 1 to enable the vertex editing mode, and let's zoom in on our custom profile like this. Now, as you can see, this yellow vertex is our first vertex, which is causing the misalignment in our panel molding. So we need to relocate our first vertex from this position to the one at this corner. So let's select this vertex, then right click and make first. And as you can see, once we have adjusted the position of our first vertex, our panel molding aligns correctly with the border of our recessed area. Now let's switch to the perspective view by pressing shortcut P. Let's select our panel molding, drag and drop our bevel modifier onto the second 2D shape like this. And now we have finished creating all our panel moldings. Let's change their color to the same color of our base molding like this. And now, as you can see, completing our panel moldings means our base molding is done. That's a wrap for part 2. If you enjoyed it, show some love by liking, commenting, and subscribing. Your support means the world to me and keeps me inspired to create even more awesome content for you. Can't wait to see you in part 3 to complete modeling the pilaster section. Thanks for watching.